13C. Write a composite function that expresses the cost of gasoline in terms of the distance driven. How much would it cost Jordan to drive 200 kilometers in her car? So first of all, we need to write the composite function where the input is the distance driven and the output is cost. So I've kind of written that over here at C, but we should also map this out. Okay, use our function flowchart to map this out. So my input is going to be the D, okay, the distance driven, and I'm going to put that into my g of d function. Okay, so I'm going to put that into g of d. When I do that, I get an output. My output is the amount of gasoline, G. When I get the gasoline, I can then put this into my C of G function. And so that becomes, the output becomes the input, and it gets inputted into the C of G function. And from there, I get the output is going to be the C that I'm looking for. So this becomes C as a function of D. So the way it looks is that the C represents my outside function. And then inside it, I'm going to go through my G first, or in other words, embed the G into that C function. So that's what it's going to look like in function notation. Okay, so when I actually write it out, it's going to be 1.23 times, and embedded inside that, I'm going to embed my G function of 0.06D. Okay, so there's my new equation, and then I can use that new equation to calculate the cost. Okay, so going to my calculator here, I'm going to do I want to calculate C, the cost when I've driven 200 kilometers. Okay, so I'm just going to plug in 200 kilometers into this. So I get 200 times 0.06 times 1.26. That's going to give me $15.12. So the cost for 200 kilometers is $15.12. Okay, so part D says, write the composite function that expresses the distance driven in terms of the cost of gasoline. How far can Jordan drive in her car for $40? Okay, so that's basically the reverse of this, or the inverse. So the easiest way to do this one would be to just start with the C of D function and then do an inverse. Okay, so I'm just going to take my C of D, and I'm going to write this as, I'm going to start with C of D equals, and I'm just going to multiply 1.23 times 0.06 to get that one factor. So it's going to be 0.0738D. And I'm just going to replace that with y and x. And I'm going to switch around the x and y, because that is now my inverse. Okay? And then to solve for the inverse, I need to solve for y. So y is equal to 1 over 0.738x. Okay, and then I can just do 1 divided by 0.0738, and then instead of using a decimal like that, I'm going to use decimal fraction. I'm just going to use a multiplier, 13.5. I'm just going to round this to 5. Okay, so there's my new equation. My output is going to be my distance driven. My input is going to be the cost. Okay, so then there's my D as a function of C. Okay, I'm just going to write it like this. And if it helps, you could just keep it as D and C through this whole process so that you don't lose track of your D's and C's. Okay, I just did it with X and Y's to show that we did an inverse here. So this is my function. I need to find the distance driven if the cost is $40. So I get 13.55 C, and then, so this 13.55 actually represents the distance per dollar. I get 13.55 kilometers per every dollar. So this works out to be 542.00. So I'm just going to round that to 542.0. And this is kilometers driven. Okay, and that makes sense because for 200 kilometers, it cost me $15.12. For $40, which is more than double, I get more than double the distance.